So, hi, welcome back to the class. So, in this class, we will discuss what is algorithms. This, uh, we will see what is an algorithm, and we will see what are the types of algorithms that are present. So, this algorithm is very important for coming to for it is important for both kids, computer science students, and data science students. So, and also, this algorithm is useful for data scientists also because with the help of algorithms, we'll do a lot of things and we'll learn a lot of things. So, algorithms plays a very important role for in machine learning subject also. So, with this help of algorithms, we can able to solve a lot of complex problems, and also we in practical life we can able to solve various problems related to the daily life. So we will see what is mean by algorithm. So we'll use this algorithm. This algorithm. Why do we use this algorithm? So 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 this algorithm plays a very important role by solving any type of problems. It means depending on the type of problems, we'll use this algorithm in order to solve the complex problems. So suppose we are having complex problems. So if we want to solve any complex problems, generally we don't use any general methods because it will take a lot of time to finish. It means there are some problems which will take some years and years and years. So by using these algorithms, we can able to solve complex complexity problems. So if we want to solve any um, huge complexity problem, we'll go with these algorithms. No, so now we'll see what do you mean by algorithms. So algorithm means it is a set of finite rules or instructions to be followed in calculations or other problem solving operations. So what is mean by algorithm means it is a set of finite rules. It means there are some rules for these algorithms and also those rules are finite rules only. Or we can also call these finite rules are we can also call those finite rules as instructions to be followed in calculations. So while doing calculations of the problem, we have to follow some instructions to solve any complex type of to solve any type of problem. So those are called an algorithm. And also we can able to call problem solving operation. So we can call this algorithm. We can define this algorithm as problem solving operations, or It is a procedure for solving mathematical problem in a finite number of steps that frequently involves recursive operations. So, what do you mean by algorithm is? It is the systematic formula. It means it is a procedure for solving mathematical problems in a finite number of steps. So, if we want to solve any mathematical problems within the finite number of steps, it means not taking any huge amount of steps. We are solving those type of mathematical problems within the finite number of steps, and also which involves those operations recursively are called as an algorithm. So by solving mathematical operations within the finite number of steps, this is called an algorithm. So therefore, algorithm refers to a sequence of finite steps to solve a particular problem. So, finally, what we define is algorithm is nothing but it is a sequence of finite steps in order to solve a particular problem. So, if you want to solve any particular problem, we will refer for only sequence of finite steps. So, those type of sequence of finite steps are called an algorithm. So, you will see with a diagrammatically. Let me show you. So here see, here is an algorithm. So we will give an input. So how we will give an input means through our text or through any kind of method. We'll give some input to any users or something like that. We'll give some input. So for that input, we use this algorithm. So there are some algorithms which we'll use for the input. So if we want to solve any complex type of problems or any difficult problems, we will use general method. But coming to algorithms, there are some certain algorithms which we can able to solve those type of complex problems within the finite number of steps. So for this input, we will use this algorithm. So we will apply this algorithm for the given problem, and we will get the required output by using this algorithm. So by using this algorithm to by applying this algorithm to the input, so we can able to solve any complex type of problems. So by using a set of rules to obtain the expected output from the given output. So if we want to get the expected output from the given input, we have to apply some set of rules for solving the problem. It means we are performing mathematical calculations, and for that mathematical calculations, we are applying some algorithm in order to solve those complex problems within the finite number of steps. So it is called an algorithm. So diagrammatically, I have shown what this algorithm is. So here we are giving an input. So for this input, we are applying some algorithms in order to solve this input. So after applying this algorithm to the given input, we will get the expected output from this input. So this is an algorithm. So this is the pictorial representation for the definition of algorithm. So next one. So use of algorithm. Let me wait. So use of algorithms. So we are having some uses by using these algorithms also. Now we will see what are the uses of algorithms in this slide. So algorithms plays a crucial role in various fields and have many applications. It means not only in computer science field, but also by this algorithm plays very important role in various fields like computer science, data science, ML engineer, and data scientist, and also these algorithms have many applications. It means we are not only using this algorithm only for computer science field, but we are using this algorithm for various fields, and also we are using this for various applications. So some of some of the key areas where algorithms are used include. So we will use this algorithms in a routine way, but in some key areas we use this algorithm. So now we will see what are the key areas that we use this algorithm in this slide. So we will see first one, computer science. So coming to we'll use this algorithm in computer science. Like we'll see the how we will use this algorithm in computer science. So algorithms form the basis of computer programming and are used to solve problems ranging from simple sorting and searching to complex tasks such as artificial intelligence and machine learning. It means how do we use these algorithms in computer science means? So by using these algorithms in the computer science, it will form the basis of computer programming. So for computer coming to some coming to computer programming, we need some basis. So by using this algorithm, it will form basis for the computer programming, and also these algorithms are used to solve problems ranging from simple sorting. So if you want to solve any problem ranging from simple sorting, we'll go with this algorithm, and we will use this algorithm say in this simple sorting and also searching to complex tasks. It means if we want to search anything in the complex task, so it means there are some complex tasks that are available in computer science. So if you want to search anything in that complex task, it is not an easy task in order to search. So it will take a lot of time. So these algorithms will come into the picture in this case, and by using these algorithms, it will make those complex tasks into the easy. So what are like complex tasks means coming artificial intelligence and machine learning. So there are some complex tasks that are related to artificial intelligence and machine learning. So if you want to search any complex task like intelligence and machine learning, we use this algorithm. So by using these algorithms, we can able to compute a complex task in terms of artificial intelligence and machine learning. So this is the use of algorithms in the computer science. Next one, mathematics. So how this algorithm is used in mathematics means suppose there are lot of problems in mathematics. So we can able to solve easy problems in mathematics, but we cannot solve complex problems in mathematics. So if you want to solve complex problems in mathematics easily, we use these algorithms in order to solve mathematical problems, like finding the optimal solution to a system of linear equation or finding the shortest path in a graph. So if you want to find the optimal solution for a system of linear equations, or we want to find the shortest path in a graph, we have to use this algorithm. So by using this algorithm, we can able to find the optimal solution. It means we can find best solution rather than the general solution. So coming to the best solution or optimal solution, we can able to find we can able to find easily. So this is the optimal solution. So we can able to find the optimal solution for system of linear equations and are finding the shortest path in a graph. So if you want to find any shortest path in a graph, it is not an easy task by using the general method. By using this general method, it will take a lot of time. So by using this algorithms in the mathematics, we can be able to find the shortest path by finding the optimal solution. It means we can able to find the optimal solution for this for the finding of the shortest path in a graph. So this is the second one. Next one. We will use this algorithms in operations research also. It means algorithms are used to optimize and make decisions in fields. So why we use this algorithm means if we want to optimize and make any decisions in the field like transportation, logistics, and resource allocation, we'll use this algorithm. So by using this algorithm in the operations research, it will optimize and it will make decisions in fields like transportation, logistics, and resource allocation. So next one, artificial intelligence. So we'll use these algorithms in artificial intelligence. Why? Because these algorithms are very, very important, and also these algorithms are foundation of artificial intelligence and machine learning. Why? Because these are the foundations of artificial intelligence and machine learning means if we want to develop any intelligent system and if we want to perform any task like image recognition, natural language processing, and decision making, we need this algorithms. So by using these algorithms in the artificial intelligence, we can able to develop intelligent systems like which can able to perform some certain tasks like image recognition, natural language processing, and decision making. So these intelligence systems will perform image recognition, natural language processing, and decision making. So, so in this way, we use these algorithms in artificial intelligence. Next one, data science. So how we use these algorithms in data science means, so algorithms are used to analyze, process, and extract insights from large amount of data in fields such as marketing, finance, and healthcare. So how we use these algorithms coming to data science means, if we want to analyze any process or if we want to extract any insights from large amount of data like marketing, finance, and healthcare, we'll use this algorithm in data science. So by using these algorithms in the data science, we can able to analyze the process, we can able to analyze the data, we can able to process the data, and also we can able to extract insights from huge amount of data. So with the uh, so by algorithms, we can have many users in computer science, mathematics, operation research, artificial intelligence, and data science. So these are the use of algorithms, and also there are some few examples of the many applications of the algorithms. So the use of algorithms is continually expanding as a new technologies and field emerge, and also this algorithm is making a important component of modern society. So, why it is impacting very continually coming to various fields. So it is very important for coming to any technologies or whether it is old technology or new technology. So this algorithm plays a very important role in various fields, and also it is making a important component for modern society. So this is what we have seen. So algorithms can be simple and complex depending on what we want to achieve. So it means depending on the problems and depending on the situation, these algorithms can be different. It means coming to different type of problems, we can able to determine whether they are simplex or complex. So for complex problems, we can able to define these algorithms are complex. For solving simple problems, we can able to define these are simple. So like that, we can able to say whether these algorithms can be simple and complex depending on what we want to achieve. So this is what we have seen. So it can be understood by taking the example of new research. So these algorithms designed are language independent. It means whatever the algorithms that are designed, they are independent of the language. Whether the language is English or any other thing, they are independent of each other. It means they are just plain instructions that can be implemented in any language. It means for coming to any language, this is nothing but just a set of instructions which can be implemented. So, if you want to implement any instructions or if you want to perform any operations in any language, they are just plain instructions, and at the output will be the same. So, whether you are using this algorithms for English, whether you are implementing this algorithm in different languages, but we will get the same output as expected. It means that's why it is language independent. So that is what we have discussed right now. So next one. So what is the need of using algorithms? So we'll discuss why we should use this algorithms and what is the need of using this algorithms we will discuss. So algorithms are necessary for solving complex problems efficiently and effectively. So for what purpose we use this algorithms is in order to solve complex problems efficiently and effectively. So there are lot of problems. So if you want to solve those complex problems efficiently and effectively, these algorithms are used. So so with the help of algorithms and by using these algorithms, we can able to solve complex problems efficiently and effectively. So this is the first need of the algorithm. Next one. So they help to automate processes and make them more reliable, faster, and easier to perform. So what this algorithm will do is it will automate the process. So whatever the process is there, automatically it will help to automate the process, and also it will make them to more reliable, faster, and easier to perform. So by using this algorithm, we can able to solve any problems in a faster and easier manner. So by using this algorithm, we can able to solve any problems fastly and in the easiest manner. So this is the second need of the algorithm. Next one, algorithms also enable computers to perform tasks that would be difficult or impossible for humans to do manually. So, what is the need of algorithms? Means, coming to human beings, they can able to solve only some little bit of problems. But coming to huge amount of problems for it means if you want to solve any complex problems, it will take a lot of years, many years. So if you want, it means there are some certain problems that are available in which humans cannot do. It means it is impossible to do such a task. So by using this algorithm, it will enable the computer to solve such a type of complex problems. So whatever the problems that are impossible for the human, but the computer will do those type of complex problems with the help of these algorithms. So by using these algorithms, computers can perform a complicated task which it is impossible for the humans to do manually. So next one, they are used in various fields such as mathematics, computer science, engineering, finance, and many others to optimize processes, analyze data, make predictions, and provide solutions to problems. It means we are using these algorithms in various fields, like in mathematics field, in computer science field, in engineering field, in finance field, and in finance field. So and also we will use this algorithm in many others. So why do we use this algorithms in various fields? If, in order to optimize processes, it means in order to get the best solution and in order to optimize process, and also if you want to analyze the data, we use these algorithms. And also by using these algorithms, we can able to make predictions in machine learning. So in machine learning models, by using various algorithms, we will make these predictions. And also providing solutions to problems. So by using this algorithm, we can able to provide different solutions for different problems. So this is the need of algorithms. Next, characteristics of an algorithm. So there are some certain characteristics for algorithm. It means for human beings also there are some characteristics for every human behavior. Likewise, for algorithm also we are having different characteristics. So what are the characteristics? The first one is well-defined input. Next one, well-defined output, finiteness, feasible, language independent, clear and unambiguous, well-defined inputs. So these are the characteristics of an algorithm. So if you want to define an algorithm, it should have some characteristics. So these are the characteristics for a for an algorithm. So if you want to apply any algorithm, those algorithms should have those characteristics. So by having those characteristics, we can able to optimize the problem. We can find the best solution for a given problem. So we will discuss each and every characteristic right now. So first one, clear and unambiguous. It means whatever the algorithm that we are giving, that should be unambiguous, and also each of it should be clear in all aspects and must lead to only one meaning. So whatever the steps that we are performing during for the algorithm, those should be clear in all aspects. So whatever the aspects that are there, it should be it should be clear in all aspects. It means they should be able to understand in all the aspects, and also it must lead to only one meaning. So this is the clear and unambiguous. So whatever the operations that we doing or whatever the algorithms that we are applying, they should be clear and unambiguous. It means it should be understandable. Next one, well-defined inputs. It means if an algorithm says to take inputs, it should be well-defined inputs. It may or may not take input. It means suppose there is an algorithm. So if an algorithm wants to take an input, we should give the well-defined inputs. It means the input should be well-defined so that uh, it is very easy to perform. Sometimes it may or may not take input. Sometimes this algorithm will take input or may not take input. So depending on the type of situation, it will take input. Sometimes it will not take input. Next one, well-defined output. It means nothing but the algorithm must clearly define what output will be yielded. It means depending on the input, we will get the output. So whatever the output that we get, it must clearly define what output that exactly we will get, and also it should be well defined as well. And also we should define that clearly. It should produce at least one output. It means whatever the input that you are giving, it should at least it should give one output. Otherwise, there is no use of an algorithm. So by applying an algorithm, at least we should get one output, finiteness. The algorithm must be finite. So whatever the algorithm that we are applying, it should be finite. It means it should terminate after applying, after completion of those steps. So it should terminate after a finite time. So after applying algorithm to a problem, after certain amount of time, it should terminate. That is what it characteristic. Next one, feasible. The algorithm must be simple. So whatever the algorithm that is there, it should be simple and also it should be generic and also it must be practical so that it can be executed with the available resources. So by having this simple, generic and practical, we can able to execute with the available resources. So whatever the resources that are available, we can able to execute those. And also it should not contain any future technology or anything. Next one, language independent. So whatever the language that we are designing and whatever the language that we are, whatever the algorithm that we are applying, it is language independent. It means whatever the algorithm that we are applying in any language, but we will get the exact output and the same output. So that's why it is language independent. Suppose we are applying an algorithm in English, Hindi, and Telugu, but we for the certain problem, but we will get the same output. So that's why it is language independent. So and here language does not matter. So whatever the language that you use for a certain problem, you will get the same output. So that is what it is saying. Next input. So an algorithm has zero or more inputs. Suppose we are having algorithm, so it can have zero or in more inputs. It means if we are not giving any inputs, that is zero input. Suppose we are giving more input, so whatever the algorithms that are there, it can able to have zero or more inputs. So so that it will contain a fundamental operator must accept zero or more inputs. So by having this fundamental operator so that it can able to accept zero or more inputs. It means having no inputs also it will accept. Having more inputs also it will be accepted. Next one, output. An algorithm produces at least one output. So whatever the algorithm that is there, definitely it must produce it must produce one output. So without producing an output, there is no algorithm. So having any algorithm, at least it must be able to produce one output. And also every instruction that contains a fundamental operator must accept zero or more inputs. Next one, definiteness. So all instructions in an algorithm must be unambiguous. So whatever the instructions that are present in algorithm, they must be unambiguous. And also they must be precise and also easy to interpret. So by referring to any of the instructions in an algorithm, one can clearly understand what is to be done. So we are having instructions in the algorithms. So by referring to instructions, it means by checking the instructions or by using the instructions in the algorithm, we can easily clearly understand what should we do with the help of those instructions. So it means by having those instructions, we can clearly understand what should we do with the help of instructions. So that is what it is saying, and also what is to be done. So every fundamental operator in an instruction must be defined without any ambiguity. So whatever the fundamental operators that are available in the algorithm, they must be defined without any ambiguity. So this is what the definiteness. Next one, properties of an algorithm. So there are some properties which algorithm will contain. So we will see. First property, it should terminate after a finite time. So um, after some certain amount of time, this algorithm should stop because um, in characteristics only it is having some characteristic finiteness. It means we should not go infinitely. So for any algorithm, there is a finiteness. So after the finite amount of time, it should be terminated. This is the first property, and also it should produce at least one output. So whatever the algorithm that is available, either you are giving zero input or more than one input, at least it must be able to produce one output. This is the second property. It should take zero or more input. It, it means mm, for a for any algorithm, it can take zero or more input. It means it may take the input or it may not take the input. That is what it is saying. So this is the third property. Next one, it should be deterministic, means giving the same output for the same input case. So whatever the input that we are giving, the same output we should be given according to the input case. So if we are repeating the same input, it should get the same output for the same input case. It is what the fourth property is saying. Next one, every step in the algorithm must be effective. It means whatever the steps that we are performing for the algorithm, that we are performing in the algorithm, they should be effective. So if the steps are effective, they will give the precise solution or it will give the optimal solution. So in order to get the optimal solution, whatever the steps that are containing this algorithm, they must be effective. And also, that is every step should do some work. It means whatever the steps that we are performing in the algorithm, em- every step should perform some work. So that is what it is saying. So by performing those work, so by performing those work, we can able to produce effective and optimal solution for the given problem. So this is what it is saying. So these are the properties of the algorithm. Now we'll see what are the advantages and disadvantages of algorithm. First one is easy to understand. It means we can able to understand the algorithm easily, and also it is stepwise representation of a solution to a given problem. Suppose there is a new problem, we are representing this presenting this algorithm stepwise. So by seeing the stepwise, we can able to understand the solution and also we can able to understand the problem. This is the second advantage. And also we can all suppose there is a huge problem. So so in a, suppose we are unable to understand the huge problem. So by using this algorithm, we can be able to break this down into smaller pieces or steps. So by breaking the problem into smaller pieces, it will become very easier for the programmer in order to convert into actual program. So these are the advantages of algorithms. So next one, disadvantages of algorithms. So what are the disadvantages of algorithms? Means writing a writing an algorithm takes a long time, so it is a time consuming. So if you want to write any algorithm for the complex problems, it will take a huge amount of time, so that it will waste a lot of time. So this is the first disadvantage. So understanding complex logic through algorithms can be very difficult. So if you want to understand complex logics behind the problem, it is very difficult in order to understand those things. So those will become very difficult. Next, branching and looping statements are difficult to show in algorithms. So coming to algorithms, it is very difficult to show any branching and looping statements. So these are the disadvantages of algorithms. So this is the introduction of the algorithm. Hope everyone understood. In the next class, Um, I will begin. I will begin the new lecture so that I will, according to the syllabus, I will begin each and every lecture so that you can able to understand. Everyone understood this class. So if you are having any doubt, please keep your doubts in the comment section so that I can able to solve your issues or I can able to respond to your comments. So hope everyone understood. So and also please don't forget to like, share, and subscribe to this channel. So hope everyone understood. Thank you guys for listening this lecture. So love you guys. Bye bye.